it's not completed. The change directory command doesn't work because it is not built into something called the exec pp function. We'll discuss it later tomorrow when we start working with the shell hands-on. But yeah, you can try installing this. And if you're on Windows, I believe you have to use WSL, and there is no other way. And if you're on Linux, then it will be fine. Just follow this instruction for Debian base and this for the Arch base. And okay, so I don't know how to do it in Gentoo or some other distribution like Red Hat or Fedora, but I guess if you're using those distributions, you'll be smart enough to know how to install the packages. You don't need much, you just need CMake and Ninja. Ninja is a build tool and CMake is used to configure or build and all. And if you're using Windows, I highly recommend using something like Ubuntu or uh, possibly Debian, so that you can follow these instructions. And yeah, the rest is very simple. You have to run this CMake command with the Ninja build tool and specify the source and build directory and change to the build directory and run the Ninja, which will create the executable and then just run the executable. Okay, so so let's move on and let's just take a quick recap mainly about the pointers. Okay, so yesterday we were working with the quick pointers with okay, so the basic structure of a program, right? We were talking about this. Uh, we have okay, so when we start our executable, we get uh, three sections in memory. We get the stack. This is the stack where the functions are called. This is mainly called the mainly known as the call stack, and uh, most of you guys are familiar with JavaScript and you have heard of the event loop and call stack. It's quite similar, just also functions. So if we have some other function like foo defined inside the main function, it will first get called, will get executed, and then get popped out of the stack, pop in and pop out. And we have some space for global variables. And we have the heap. This is like the endless source of memory or rest of the computer memory. We can use functions like malloc, calloc, or uh, to access the heap memory, and then we have to make sure that we use free so that we free up this memory, and you know uh, we don't just create a memory leak, because if we don't allocating memory without freeing it, then eventually we'll run out of memory. So and that's the basic structure of a program. And what I wanted to recap quickly is the concept of pointers. I won't show you the loops or the if statements, because I mean they're quite similar to any other general purpose programming languages. When I will show you the syntax, you'll automatically get the gist. But pointers are something used by the JavaScript and Python developers, or any other general purpose language developers. So let me just quickly go over pointers. So pointers are nothing but they are okay, let's see the text box. Pointers are um, variables. They're like normal variables that the store the address of another variable. Okay, so this is the basic textbook definition of okay. So if we have a variable, let's say a, and we initialize it to 10, and then we create a pointer, say okay, say b star b. We have already written it in int, and we pass the address of a. So this ampersand sign, this is uh, the reference symbol. It provides the memory address that this variable a contains, and then pass it to this pointer which will point to this address, and then if we just print the value of B, we'll get the address of A. So this is like a general formula, address of A. And if we uh, print the value of, let's say, star V, star means dereferencing the pointer that is taking the address and printing the value that is stored in it, we will get the value in A. Value in A. Okay. So that's the basic rule of thumb. And why are they useful? Well, they are used with various functions like malloc and realloc and functions like that. So if we just take a look at the man page real quick, we will see the use of pointers almost everywhere. So malloc is used to allocate memory in the heap. I have discussed this function yesterday, and I won't go into the details and implementation of it today, but I'll just give a quick overview. We won't be using malloc or making our final project. We'll be using other basic functions, but this is quite an important function. Okay, so we have malloc, free, alloc, realloc, realloc array, uh, allocating free dynamic memory. So these are functions that allow us to interact with our heap memory. Malloc, you can read about malloc in the man page. So the most important thing that I want to highlight throughout this workshop is the importance of this manual page. Okay, in Unix operating system, we get this man page, and it contains a lot of information about the function. Most importantly, the synopsis, what header files we need, so that we can easily get started with the function and use it. Uh, I don't really know the syntax of most of the function, even the functions that I'll be demonstrating today. I'll just heavily use this man page to read the synopsis, to read the return values and all, and work with the function, because that's how we do it. We don't memorize things in programming. We just use references like this. We use Google, and yesterday I believe I provided a very interesting resource from IEE about the POSIX standard and the header files. This, you know, kind of file. There we are. Okay, I'll just paste the link. Uh, just copy it and paste it in the shop channel. Okay. Okay. So there we are. Um, the most important part of this whole website is this headers section, where we have all the headers associated with POSIX API. So POSIX is a standard that a lot of Unix operating systems, including Mac, uses to provide a API to interact with the operating system. It just makes it a lot easier for the developers to create applications in the low level, because uh, we don't need to worry about the implementation in various operating systems. So with this, we can easily target all of the Unix operating systems, and we have a really interesting stuff defined here. Like we have string.h for every string function, standard lib.h, stdio.h, where we have our printf, scanf, and all those functions. We have wait.h. We'll be using wait.h when we'll be taking a look at sockets, and we'll also take a look at, I believe, termoist.h is just entered to the terminal. netdb.h for socket programming. We'll take a look at that. And we'll also take a look at, I believe, strings.h. And I really found a very useful program, a function in the library, which is lesser known, that is b0, that is used to initialize everything in a buffer with uh, 0. And well, that's a very useful function, and we will see its use case when we work with our shell in day 3, that is tomorrow. Okay, so we also have openIST.h, and it also contains various functions. Uh, if I just scroll down, yeah, there you go. Okay. Mhm. we have uh, some function declarations here. We can read about this all these declarations while we use our uh, man page. So like if I just do man close. Okay, so the manual pages various sections, some associated with the shell that we're using. I'm currently learning fish shell, so some of it will be associated with a fish, some of it will be Linux specific, or some of it will be associated with C. So we can just jump over the sections using the we're using this number icon. So by default it's one. Okay, by default it's uh, nothing. So it's like it'll open the default first section. But if we want to navigate to the second section, we can use the two. We can't use one. You can use two, and there's close the file descriptor. It is used to close the file, and we can read all about this using this man page. It is not humanly possible to cover each and every one of the functions in each and one of the um, structures and data types defined in all of these other files. On I don't have a good idea even about this header files too, mainly because well we don't use it every day. We just use it when we need. That's why it is very important to know how to use this man pages to uh, learn about the function to quickly use it. Okay, that being said, let's jump into some action. Okay, so the first thing that I want to cover today is um, opening a file and then just reading and writing data to it, right? Uh, we will also cover the read and write functions while working with this. Okay, so okay, let's start then. First, we'll do man open. This will be man section 2. There is system call manual, standard C library, and there are instruction on how to open a file, and the function that we will be using is the open function right here. We don't we'll be using the first one. We also have a second one. It is provides a third argument for, I believe, the read and write features. Well, you can read the description here. It will also tell us about what this flag command is. So the open system call opens a file specified in the path name. I believe you can see that now. Uh, if the specified file doesn't exist, it may optionally create the file. If we just provide this o create flag, then if the file doesn't exist, we'll create a file. Uh, really okay. Okay, it will return something called a file descriptor uh, that is used to uniquely identify file. Um, Okay, so it will return a file descriptor, and then later when we are done working with the file, we will just close it with the close function. We'll just pass the file descriptor to the close function as an argument. We can also use this file descriptor to interact with the read and write. So we can just specify the file descriptor and we can read data from it, and then we can also write data to it using the file descriptor. So the standard input, that is the input from the keyboard, it has a file descriptor of 0. The standard output is a file descriptor of 1. So it will have so each and every open process or file have a unique file descriptor. So when we first open a file, it will return us with a unique uh, file descriptor. And another helpful resource, and I guess everybody knows about it, is Wikipedia. You can just Google it and read a Wikipedia article, read the first few lines, and you will get the gist of what something is. Okay, so let's just start to work with this open function. So I'll just go to my documents directory. Okay, so we're working with this. What is it? Okay, with this C programming workshop folder. Join this address. Okay, so it's kind of messed up right now. Let me just delete this file because we won't use it today, and then just create a thing with open func. So we'll just create a file and just try to uh, write data to it and then read data to it. So that will be our first task for the day. Let's get file even. Okay, search demo. So it will be a demo for the open function. By the way, the source code I will I guess make it. I will request design and code team member to create a GitHub repo so that we can host this code that we write today uh, in this session. So created a new file called open uh, demo. So it will be a demonstration for the open function. We will just open it in new open. Okay. So first we will need a few header files, right? So, open. Okay, so this is the first page of the manual file, and this is the fish shell. We won't be working with the fish shell, so we don't need this. What I want is the standard C library, and this is the standard C library system calls manual, and we need this fc and tl.h somewhere in here, or maybe not. Oh, there it is. You can read the functions defined in this file by create fc and tl open f and POSIX f device and f bit. So frankly, the only thing that we need to worry about is the open function here. So we'll just need to include this header file because the function is I believe I'm spelling it right. Okay. The thing that we need is our main function, so we can just get started. And okay, so first thing that we'll be getting is a file descriptor, and I'll just use integer for it. I guess to return. Yeah, it will return in. So the file descriptor, it will be a unique integer to identify each file. So I'll just create a file descriptor. File descriptor. And first, let's create a file. Okay, file descriptor equals the open function, and let's just name it demo.txt. And so we don't have this file created yet, so will need to find specify this o I believe okay okay create and uh, wait, I also want to write this, so I just add a o write only. So I'll only write to this file for now, and we won't just these are the two arguments that we need. So we either use o create or we'll either use o write only, and then this then let's read what this function returns. So if I just scroll down, yeah, return value on success, open it and create returns a new file descriptor and non-negative integer. That's what a file descriptor basically is. On error minus one is return and error numbers to indicate the error. Okay, basically something. we need the PR because it's showing stdio page. So basically, it is used to use one if we encounter error in our program. So if this file descriptor will be uh, in -1, then we'll print an error message saying uh, failed to create slash open a file, and it will exit out of the program with a 1, which means well everything didn't went as we planned. Then okay, then close the file. Close file descriptor. So the close function is used to just close the open process or file or whatever, right? Just try to run it. Okay, so gcc and the file name. Let's see, the output will be. Okay, so we have error. Okay, so this will be the close function, and okay, we need to include this file for the close function. And also we need something for the exit, I believe. So, okay, it's related to the shell. Okay, standard library. Okay, mm, I guess we need the standard level anyways because we'll be using uh, read and write to write. And we'll just try to compile it now. There we go. Okay, so nothing happens because we didn't specify what we want to do when we just first created this uh, function. So if we get a -1 response for the file descriptor, we will encounter this error. But what if we get a success response? Then we'll need to do something with the file, right? And I have set it to write only, so we need to write something to uh, file. So okay, so I need to first create maybe a string. Just name it box and just give it a size maybe. I mean, we will keep to 4. It will be a really long string on it. Just go. Let's go to small sizes, like 14, and then we need the write function. So write. Okay, it's not the C version of it. Man, to write, and there is the standard C library. Even as the storage we already have included it, it returns a size D. We won't need to worry about this because all we need to worry about is this buffer where we want to, write our data. So write up to converts from the buffer starting from buffer to the file refer to the file descriptor. Okay, so it takes a file descriptor as an input. It takes a buffer, the buffer where it needs to, you know, the buffer that it needs to write data to, and the size of the buffer. Okay, the buffer which stores the data, my bad, because we're writing, we're not reading from it. And the number of bytes written may be less if for okay. There are some edge cases we don't need to worry about it right now. Just go to the okay, written values on success, the number of bytes written is return on error minus incident. We won't handle this error by using the if statement or all, but we'll just try to write it, using this return value. So yeah, right, right. The file descriptor, it will be uh, it will be one if we write to our terminal. So just do one and then just write hello world. And then, okay, so just mm, world, you can see we get our get a text terminal like we get in printf. So this is the standard output. It is specified with the integer one, but our file will have a different um, file descriptor. This integer will be unique for the files. We'll just provide the integer provided to us by the open function. So descriptor. And now if we just run this and do an ls, you can see we have this demo.txt file. And now if we just okay, just get this file demo.txt, you can see permission denied error. So we have an error in here. Mm, just, and, okay, so we still have an error. File descriptor. Okay. Okay, if we just try to write it without the booklet. Will access and manually specify size like every 13 characters long. And if we just close this bracket in here, and then this. Okay, so the file is created successfully, and we still get the permission denied error. Okay. Mm, okay, what if I use the other version of this open function? I have another function version that uses a mode key argument. Just want to check that for permissions, file permission and all. Okay. Okay, these are the symbolic constants for mode, and we try to find find the one that we need. Okay, this is right permission, right? SIWUSR. Let's just try to get it. Okay. Still there is a permission denied error. If we use something like, oh, okay. We do get, oh, okay. So this was a issue associated with a file. So just remove this and do this and try to run it and do a sudo get. Just ask for, okay. So if I do an ls, you can see that the me as the user don't have the read permission in here. So that's the main issue going on. So if I with this file, okay, so I guess we fix it when we work with the file, when we work with the read value of the file. Okay. We need this buffer anyways because we will read data from the buffer, yeah, and here for now. And we'll create a new descriptor to read the data and print it to our what do you say, standard output. Again, use this section to read, and we'll create a new we'll override. We'll just create a open, and we'll use this demo.txt file that is already created. So since it's already created up here, we don't need to use uh, create. We will just only use read only because we'll read from it. Read R, okay, it's RD only. I remember it's only AD, and then same story. This fails, we'll just this time restring here, and we are failed to create such a to read the file, and then we just read data from it. So read, we will use this file, this store, and the buffer and size will be 13. So we'll then close this file descriptor file descriptor, and also print this data uh, to our standard output. Right, the one for the standard output. Get that for and leave, okay, 14 characters in the buffer. So the last character of the so the yeah, 13 in here. Okay. Okay. So again, we have some permissions issue that is issues associated with the Unix operating system. I guess we just need to provide the read write flag if there is any. Okay, RDWR. I think that will work. RDWR. And we get the same error. Okay, first off, exit this. And then see, read this file descriptor and the data to it. Hmm, it's very clear there. Fail to create special component file, permission denied. Yes, this demo gives initially and then just oh, there we go, we have the answer. So the earlier demo.txt, it doesn't have the privileges for reading data from it by this program or by our user. So it was showing an error. And since we did it, create a new file from scratch and we can read and write the reads. And now if we just scatter them out, well, it works fine. So this was our first demonstration of reading and writing using a file in our center production file descriptor. So you can see it's not long, it's not a very huge code, but again, you have to be, clever enough to use the man pages provided, man pages, and this very useful resource right here, the POSIX standards, so work with all these, right? So let me hop into the and see if any one of you have some doubts. Okay, okay, okay. So does anyone have a doubt? Okay. Yeah, this was right. Because we have to change the uh, change more for and I figured it out quite late. I believe I should have checked the channel a bit earlier. But anyways, I guess it's all clear in here, and we can move on uh, to our next segment. Mm, what shall we go next? Let's see. Okay, so for these course, I won't cover P-Trace because it will be a bit complicated, and I really wanted to touch on sockets because most of you are from a web development background and you guys work with sockets almost every time with real-time dashboards and real-time chat applications and all. I guess you all are familiar with Socket.io. You all are familiar with, I guess, WebSockets in general. And so we'll be doing a bit of socket programming today. But before doing that, we need to touch on a few important functions. That is the fork function, which is used to create a new process from as a child process of the current process. It will be very useful to work with the shell because the basic goal of the shell is to create a new process and execute a command. And we'll touch on that today, and we'll also look at the terminal storage library to try some terminal configurations to play with the terminal a bit, play with the terminal behavior. So yeah, let's move on to the fork function. Okay, okay. So close this one, and from here and man was I believe okay. Menu of extension modules not all and two, and a system calls modules and let's see library create a child process. So it means this unistd.h file, it returns a PID, which is a special data type stored in the sys types dot h header file, the header file that I showed you yesterday. And then sys sys types, there we go. The range, close it. So we have our uh, PID summary list. There it is, PID used for process IDs, process group IDs. Okay. So it returns a new process ID. So what are processes? So every instances of a program running in our operating system is a process. So this is the fish that I'm using. So it is listed as a process. If we just list every process, you can use this very useful command. Okay, so this is the everything that's running on my computer. So you can see the user, most of them is root because this is the core processes, the system processes that is okay. The system processes that run on start of the root processes that are vital for program of the operating system, and then we have the user processes that I created for some reasons. Maybe the Xorg this Xorg allows us to display all this nice GUIs, or else we'll be stuck in a shell. And the PyCom this allows us to have this nice transparency in this apps like LRPP and Roke. This allows us to have this transparency and this rounded corners. We have ton of other processes that we are using. We have Discord over here, and the processes associated with Discord. And, and yeah, meant to forget it ran as a process because it is still running here, right? So it is a process. So if I just close this, close command, and just the process. Nice. AU segment. Okay, so the alarm it got replaced by electric with a terminal emulator. And the main to fork disappeared because we closed the process. I'm going to reopen it because I'm going to need a reference for the function, and slash user slash bench slash fish. This is the shell that I'm currently running. The PSAUX it got listed as initiated process even though it's closed right now. We have a lot of other processes. Okay, we want to create our own process. That's the goal. So let's get started. We'll be using the fork function. We'll create another view for now. Working with open function. Fork. Okay, so as a matter of fact, I know I will need three very important libraries. The first will be the template.h, and HTTP. I will also need a leave on type storage. Yes, types.h because the PID and well, let us include stdio of h. We might use the print function somewhere down the line. The, with the main function. First up, let's create this has an ID. PID will be the ID of the child process, and, okay, PID is the fork to create a new process. This so the fork having no argument. This right, it takes no argument, so we have uh, void in here. Then okay, so we'll just print the PID for now. Let's see what's there. Okay, so I believe it will be an integer as I use it in comparison. So I'll use the %d flag here and pass the PID. Let's see what's in here. Okay, I made a spelling mistake. Um, okay, unknown type. Oh, okay, made a mistake. PID underscore T. That's right. Yeah, that's right. I'll leave it work now. 8 on. Okay. Okay, so we have this uh, ID in here that got translated to 0. Okay, so it's as a matter of fact, we can create multiple sets at once, right? PID 2. Let's create another process. Let's say PID 2, another fork. Okay, there we go. I'm just gonna yank this, paste it, and PID 2. Let's see. Let's see what happens. Uh, okay, probably I should print a new line. Okay, so PID 000 and PID equal to 8455845686 was translated to 0. Okay, so let's just see the man page and see what this means. Creates a new process by duplicating the new process. Okay, so child process, the calling process is reflected as the parent process. And return on success, the PID of the children process is returned in the parent and 0 is returned in the child. Okay, on 3 0 minus 1. Okay, so 0 is the return ID for the child and PID return. On success, the PID of the child process is returned in the parent and 0 is returned in the child. Okay, so, let's just delete this and we'll demonstrate. Equals 0 print add hello there and here. Very similar statements, but okay. So hey there got printed. The child process ran twice, and the parent process also ran twice in the meantime. So if I just comment out on child, then I guess we'll get there. We'll run once. Yeah, we ran it once. So basically the parent process and the child process got executed at the same time, and the child process we got the PIDs always is zero. So if we have, even if we have multiple child processes, we'll get the PIDs zero, and then we'll just print this statement, and then at simultaneously we'll print the parents statement as well. So this is how it for function basically works. So so to return -1, so you can just get an arrow f PID equal -1, then p error can't work, can't create child process, and exit. We need to exit out of the program as one. Okay, so same story. Now we can do anything inside the child process, and the parent process won't get executed. As a matter of fact, you can use a wait call. Include okay, and slash wait.h. I believe this one wait.h, and let's delete this line. Wait, it's null for now. And run it. Run it. Okay, we only got the hello there, and the parent process didn't got executed while we uh, ran this wait call. So it asked our parent process to wait until this child process is over, and then if it's print statement here. Hey there. Okay, got it. Print f, and here we go. Okay, we got hello there, hey there, and then hey there. Uh, oh well, it got executed as a part of the parent process, right? So I just delete it and paste it here. Wait a second now. Yeah, we only got it once. We didn't got it twice. And delete this and okay, we didn't got the wait. So wait, we can use this function to stop the execution of the parent process while the execution of the child process is going on. We can look at the main page for more details. Section 2 of the main page. Wait PID waits for a process to change state. Okay. All of the system calls are used to wait for a state change in the child of the calling process and obtain information about the child whose if the state change is considered to be the child terminated, the child was stopped by a signal, or the child was resumed by a signal. Okay, so this function stops the execution until and unless the child process changes its state. So if we can just do a loop in here, int I for 0 for I less than 10, I plus plus, and then do print f %d and the new line character, and then I, and then just terminate it, and then put some gibberish in here. Print f the guy, and then we just compile this program run it. Okay, so it waited until all of these values got printed and then executed this parent function. So uh, so this didn't got executed until the child was terminated. It got terminated as soon as the last print statement hit end. This is how this works. So you can read more about wait and there is a ton of variants for this function, but we'll need mainly the wait function. It says it needs a pointer ws status as an argument, and we can read more about this status in this man page as well. So mm, okay, I just have I had read about this. Okay. The wait system process when execution and calling thread until an official document the code is equivalent to repeating the wait period system process. PID can be any child processes from zero. Child has okay, so there are various options to this W as status pointer, but we passed in a null pointer, and then the default behavior that we got was waited for the process to be terminated, and possibly this is the only behavior that we need in most cases. But if we have a more advanced use case, which is well not really likely, but then we can use all of these flags to manipulate its behavior. I mean, it will be more beneficial if we start working with threads, but we won't cover threads at least in these workshops because well, it's too advanced for this kind of a workshop. But if when we start working with threads or maybe more advanced stuff, then we'll use all of these uh, status arguments. But for now, we just only pass null and we'll get our job done. And maybe this is the only thing that we need in majority of the use cases, if not all use cases. So this is how fork works. This is how a process is created, and yeah, that's it. Let's see. I was going to chat if anyone has a question or something like that. Okay. So I see no questions, guys. You can just type clear or something like that if you guys um, guys don't have any question and proceed. That's great. Let me just pour a cup of coffee. As a matter of fact, I have made nearly 3 cups of coffee for this workshop. That's great. That's great. Oh, okay. I really have a kettle like behind me to as a quick supply of coffee. It's intensive, so we need to take a break. Okay. I guess. Did you fix the laptop issue so we can do a bit of collaboration or something like that? Are you done with that, or do you still have the issue persisting? If the child process is running and we try to kill, so does it kill it or wait till to finish the process? Okay, So if we just try to exit the system, okay, so if I just uh, give a exit point here, so okay, if I let's say 5 into the right, yeah, if I equal to 5, exit is 0, then and then save it and then rerun it and then re-execute it. Okay, we got till 5 and then the process got terminated and then the this goodbye the parent process got executed. So this exit 0 terminates the child process, not the parent process. Please note that. And then the execution of the parent process continues. But if we want to terminate the parent process over here, then let's just do it. Exit 0. We don't need the goodbye statement and all. Leave it there and do this. Okay, still we printed all of the child process and then only we exited. But if we just it also depends on the location of the statement, right? If I just put it here and then save it and then execute it and then just run it. Well, it's still waited because the child process finished first and then the execution of the parent process is done. So I hope this clears it. This is the default behavior for this function, but yeah, let's undo everything. Okay, set it to the default state. Post use. Oh yeah, you can definitely use the signal, but the behavior said it will wait until the child process get terminates, and then only will kill the subsequent parent process if we run the exit call in our parent process. If we run the exit call in our child process, then our child process will get terminated. The execution of the parent process will still continue, and this is very relevant when we will start working with the shell. So while working with the shell, let me just give a sneak peek into the source code of the shell and close all of this, close this too. Just go to the documents, then documents, the DC shell, ls, open the new directory here. Shell details which contains the utility function for the shell and its execution. Okay, so this is where the child process gets created. Okay, so what the shell does is that it creates a new process for execution of a command, and then okay, the child process is created in here, and this gets executed, and then we exit the entire child process, and still the program keeps on running, and then we wait until the execution of child process is completed or the child process is entirely terminated. And we use this exact video. We won't cover this today, we'll cover it tomorrow while we work with the shell. This is a very simple command to, emulate the behavior of the shell. Okay, and as a matter of fact, it doesn't include the cd command. So we have to manually, specify this as a built-in command. But the basic function of a shell is to handle this behavior associated with uh, forking and creating a new process so that we can execute a command. And the execution of a command, well, we use this parser or this executor, and we also provide some built-in commands if we want. I'll create a few built-in commands and commit it tomorrow. I have a lot of time for that, and actually the shell is basically ready except for the change directory command. And yeah, so we'll take a look at this tomorrow, and this will be very interesting and something that I will really like to show. Here we are. Okay, so shall we go to socket programming? So let's go to socket. Wait, did I forgot something? We covered the basic read-write operations, the fork and child processes. We won't cover threads today. today because socket programming is uh, a bit lengthy subject. We encounter multiple functions inside the socket programming. We will cover this exact VP tomorrow. And yes, I will link a very useful playlist by a programmer called Shelby, and I'll just link it in the course, in the project repo or in this course repo, so that everyone can access it. I will also link this IEE process specification. This will come really handy while working with uh, C, because this playlist mainly is all what this course is all about, right? This when you seeing this playlist, you see the extensive views of the main pages and how all this function works. So yeah, it's a very exciting playlist, and definitely recommend checking it out. It's 7 years old, it's quite old, but as they say, old is gold. So, so yeah, check this playlist. It also contains uh, things associated with threads and all. And if you want to dive deep, then you can definitely use this playlist as a resource along with this documentation. And also, I believe I forgot to talk about um, buffers and all, right? How the data happens. So bookmarks. And let me just go operating system. This is a really helpful website that I found related to the various concepts of operating system. And I'm going to show the what is it? I forgot the name. Streams. There, streams. That's right. So the stream mechanism in Unix provides a bidirectional connection between user and a device driver onto which additional modules can be read. So this is the standardized way of communicating. So our file descriptor uses this process. So the user process and the device driver are shown as an example here. You can also take our C program and our file as an example here, and then this is the stream that allows us to read and write data simultaneously. We use the read and write functions to interact with the stream, and this is a standardized way provided by the operating systems, and it is a part of OS programming and operating systems in general. And well, this is beyond the scope of this course, but again, give it a read. I will just link it. This is a really nice website that covers a lot of OS related topics that are very uh, handy while understanding all these functions like read, write, and all. Okay, so yeah, let's move to the big part. Let's move to socket programming. And the first thing that I want to show you guys is what we will be building. So recently, I have built this demonstration of a WebSocket using this TCP IP protocol. So if I go to my GitHub in the repository section, and yeah, there is a client server model. There we are, and this basically allows us demonstrate the behavior of a client data server, how they interact uh, in local environments. So if we just go on to this image and see, okay. So socket readers with binding socket. These are all the processes associated with a socket, and then we just take a message from the client, and then the server gets the message, and then it can send a response, and vice versa. So we'll be creating something like this. So I'll be using this source code, and we'll just create it from scratch. But still, I might refer to it sometimes because, well, we don't need to reinvent the wheel, and it will really take a long while if we just start if we debug everything on our own. And I already have done a good job in creating such a repo. So definitely, I'll just link the repo for you guys to see. And for the sake of simplicity, I won't be handling multiple processes and all because it will really be very complicated. But again, if you guys want to interact with it, or expand it, or contribute it in some capacity, you can definitely uh, uh, submit code. You can definitely play around with it, tweak it, and all. But yeah, this will be important uh, resource material while working with software programming for this workshop at least. It's not a perfect implementation, but if it works, then we can use it, right? So it works. So let's see in action live. I have to let's where is it? There is the client server model. Client server model. There we are. Oh yeah, good. But we don't need that. So if I create two terminal windows and maybe go here, client server model. So we'll use this for the client and we'll use this for the server, and we can do server in here. You start the server and then just put the client in here. Okay, so it connects to the server and the server displays this new status connected, and then we can enter a message that is maker to the server, but say hello. Something. This will be the nested bit hello. Okay, and the client says hello. We can send a response, and just keep on typing stuff, right? And the communication works. Okay, again, it's not perfect. It definitely has bugs, but again, this is the implementation that we can work with. So we'll close this. Okay, okay, nice official. C programming workshop. C programming workshop. Okay, and working with open function, working with for function, and working with uh, socket working. So we'll be implementing this from scratch, but we'll sometimes use the HTML code as a reference because it will save us a lot of time, and we already went at it for maybe 1.5 hour now. Now it's almost 1.5 hour, and uh, I believe we will be sticking around for another uh, half an hour, and then we can conclude this after we complete this uh, socket thing. Okay, I guess I want to show you something else related to this socket programming. Let's go with socket programming, and yeah, there it is, the IBM article. So it has a beautiful diagram. Let's just let it load. Okay. Mm, there we are. There's documentation and let's see. Socket creating basic socket design, I guess. Creating connection, creating connection. Oh, there is, I guess. Okay. Let's zoom over and the socket. We can bind it. We can then listen to the socket and then execute result. Uh, connect to the then the client can connect to the socket and can pass the messages back and forth. This is how the socket works. Again, if you want to go in depth, then you can read this IBM article. It's probably linked down below. Socket programming and then just copy and then paste it here. Okay, so you can read this articles of course. I've been muting my mic for just a second. Okay, I'm back. Um, okay, let's continue. Touch client dot c. So this will be our client and touch server dot c. And then we have our server. So let's start it. And so the model. Let's just do server first. So so in the define of it, wait, let's first include some of the functions and some of the data structures that we'll need. First, we will need a socket address, something to denote the address on the socket. So we can just find sock addr, that's right, and c standard level sysless socket address. So this is where the specifications of the socket, like the port number, the family of protocols that we'll be using, we'll be using the internet protocol, TCP and the IP protocols, and the address of the socket and stuff like that is stored, right? So we'll first need a structure to store all this data, right? So first, let's just include socket age. First include std age, and then system socket age. And if we just look in here we can see sys slash socket.h. Yeah, there's the file, header file. We can read about it here. We'll definitely see the structure. Somewhere here, these are the functions associated with socket. We'll use a lot of the like bind, connect, listen, and I guess we'll also use socket, the basic socket function to create a socket. Yes, and definitely have the structure. Okay. Yes, this is just this the socket of headers to define. Okay, this is another header. We need this header because this is the one that stores the address and the configuration. So headers will define the soft ADDI header, which will include at least the following members, and to define socket addresses, which is used in all of these functions. So so yeah, first let's create a socket header. So it will be a struct. It is a structure. So structure it's like a um, it's like a basic data structure to store values of various data type, right? So you can define your own structure by doing this struct a and then int roll number, whatever, for a student or something like that. So you can store our name 26 and all. So you can store variable data types. I won't demonstrate the working of the structure, but you get the gist. It is used to store various elements together as a group. So if you are working with a game, say you want to store the x and y position of an entity along with its velocity, you can use the structure. So struct, and then which structure we want to use. We want to use this uh, socket address, but we want to use the socket address IN structure. So it's a bit different. We have socket address and socket address IN describes it is used to work with the internet protocol, so it's used to define an IPv4 address of the socket. This is related to how the socket programming works, and inside of it, I won't dive deep into the socket programming, but we'll get the gist when we just start working with these functions. But basically, it contains all of these things like the family, the port number, and the address and all, right? And yeah, that's it. So create a client and then just name it server and another one for the client that will connect. So we'll deal with two sockets, right? So the socket is a two-way combination connection. So we'll have one in the server side and one in the side. And we'll get a file descriptor. It will be an integer data type. So server file descriptor and connection file descriptor. And this is what the socket call will return. When we create a socket, it will return a file descriptor that is used to initially identify the socket. Will see file descriptor being used everywhere. We have already seen it being used with files in the open function. We have seen it used with the standard input and standard output, and also now we're seeing this being used with this sockets. So now to define a couple of things to start. So has define is a preprocessor directive. So it just happens before the compilation of the uh, program. Preprocessor is a preprocessing is a process that happens before the compilation of the program, and we can define various things, and then we can use them in a program, and all of the values get reevaluated or changed while the compilation is done. So this is like alias for a lot of values, and then those values get replaced with the original value as before the compilation of the process takes place. This is associated with how the C compiler work, and pre-processing is the integral part of uh, working with the compiler. So we use this as defined to define a size that stores this 1024 value and a standard input to store the the value of standard input, of course, um, which is zero. Standard input is zero, and the standard output is one. There is a standard error that's two, but we won't interact with the standard error now. And, and let's just create a socket now. Create socket, and it will return a file descriptor as I already told you. So it will be the server file descriptor. Server file descriptor, and we'll use a socket function. So let's look at what the socket function actually is. And socket, socket, okay. Create an endpoint for communication. This is a definition of a socket, and takes a domain argument, a type argument, and a protocol. Okay, so the domain argument specifies the communication domain. It selects the protocol family. Okay, so it selects the protocol family to be used. Like the internet protocol belongs to uh, this. Let me just take a look at this. INET protocol, I believe. That's right, the INET protocol. So the TCP and IP belong to the INET protocol family. So first it takes the family, then it takes the type. So the type of the socket, there are different types of socket. One is the socket stream, that is where the data come in as a stream, provides sequential, reliable two-way connection based byte stream. So the streams that we saw while interacting with the device driver, right? So it's similar to that. It is also for there are also other types like for connectionless, unreliable message of fixed maximum lengths, and there are quite a few of them you can read. But the most important and the secure one will be the SOC stream, and uh, it will allow us to read the data and write the data as streams, which is the standardized way of working even in the operating system. So we can, of course, use the read and write file to write to the file descriptor. And it takes protocol. Okay, so the protocol argument. The protocol specifies a particular protocol to be used. And normally, only a single protocol exists to support a particular socket type within a given protocol family, in which case protocol can be set as zero. So we'll specify it as zero because in the INET family we'll also get the TCP/IP protocol only. We won't get any other protocols. But if if we use a separate family for a separate occasion, then it might have more than one protocol, and then we specify the exact number. But if there is only one protocol, we just use zero. And the INET protocol family only have one protocol, that is the TCP/IP protocol. So we'll use zero socket, and then copy with the protocol family INET, and then the next argument will be the type of string, and then the protocol family number should be zero. So we have our basic socket here. Now let's look at the return type. Return value on success of file descriptor for the new socket is returned or -1. Okay, so if it is -1, then we'll know it is an error, else it is a also successful in creating a new socket. So if server descriptor is equal to -1, then it's throw an error and say uh, failed to create socket, and then exit one. And I believe I have to include a couple of files, and I should do them already. Let's include let which MySQL and okay, error, and else we'll just move on. Enter socket created successfully. And okay, let's try to compile our server. C server, C server. Okay, server client. Okay, client is in okay. So storage size of server is in hmm, systems. Sorry, yeah. Oh, we have to include another header file, net init slash in.h. Still get the same error. What's wrong? So client and net init slash net init slash in.h, and did I forgot something? Okay. are getting this error. Um, Server file descriptor software soft stream and 0. We need, I guess we need 5 storage. And it should be working now, I believe. No. Error storage as a client is unknown and the server is unknown. That's not really good description. Mhm. Does anyone have an idea where I might be wrong? The working file. Let's see. Should also have a, I believe, netdb.h. That might be a case. I really haven't seen an error like this. That's weird. It's another idea. Um, so, oh, that might be a case. Oh, that's the case. Interesting. Oh, thanks. Thanks, bro, right now. Okay, so we finally created a socket successfully. There was a typo. I apologize. But this happens when you do programming, right? This is very common. And well, let's move on. Then let's assign this socket uh, some configuration. So socket configuration. Okay, again, type. So the server, I want the accessless family. So I want to target the protocol family, and I want to make it inet. Net. Okay, so to assign a unique address to the server, we will need another function, and that is HTML. So HTML function converts the unsigned integer from host byte to network byte order. So all of these socket and network protocols uses something called the network byte order, and this function allows us to interact with this network byte order to convert our integer or uh, other values into network byte. So, so, mm, so first we need to include that header file, right? So we need r plus this and 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 we'll need to we'll use just a random address, so we'll do the function and then use this imdr slash any to assign any address, and dot will specify port number to interact. That will be instance and port 8080, and we're basically done now with the server configuration. I hope I haven't made a typo again. And now the next process associated with socket is binding. So this is socket programming. We have to go to basic socket, I believe. Where is the socket programming? Basic socket design, I guess. Creating function socket and okay. Socket represents socket is represents an endpoint just also identifies the interpretable. Okay. The set socket option allow the local address to be used on the right now. I want to see where the bind function is. So this not here, so I have to just find it in the man page, I believe. Okay, there we are. Bind the name to the socket. When a socket is created with socket function, it exists in a namespace address family but has no address assigned to it. Okay, so we have to assign an address. Bind assigns the address specific by ADDR to the socket referred to by the file descriptor. Okay, so this is vital for the internal working of a socket. This is used to assign the address of the socket itself, and the address okay, in the eyes of the address. Okay, so the address that we manipulated here as ADDR, it is used to assign this address to the socket. So we have to use the bind function now. So we'll check if the bind function works, because it, it returns a -1 if it fails to uh, bind it. On success, 0 is written, on error, -1 is written. Right. So if bind and then the file descriptor, the server file descriptor, and we have, I believe, the address. Okay, so the address is a soft ADDR type. So we need to convert this uh, to the structure. We need to typecast it soft ADDR. It's quite simple. You can just do it this way, and as our server, and, and finally we need this size. So we have to do size server, and if it's equal to 0, binding successful, and when you bind we need extra few dots. Like here, and else. So if it is not successful, then just throw an error by fail, and We'll just exit out of it. Now let's just run it, and it works. Okay, so next step is listening. So and listen. Okay. The listen function will make the connection more socket specified to the socket argument by accepting. Okay, so it allows us to accept connection. So we can just so that we can accept the connection. Okay, so the listen function shall make a connection more socket specified by the socket argument as accepting connection. Okay, it denotes that the socket is now accepting connection, and it requires the socket as the argument and a backlog. So what's the backlog? A backlog argument of zero may allow the socket to accept connections, in which case the length of the listen queue may be set to an implementation defined minimum value. And I guess this is just the number of uh, devices that we want to connect to. It's called the backlog argument of value that is less than zero. The function behaves as if it had been called with a backlog argument value of zero. The implementation may include incomplete connections in relation to the limit. The implementation may have upper limit and range of backlog is whatever the hell is. Okay, so how many devices can basically connect with this? This is the backlog denotes. So then let's start listening. And here, listen, and then wait. Server file descriptor, uh, and then we have to provide a backlog, right? So let's go with 5 for now. And then if it's successful, that if it returns 0, we need to print listening. That is, we're listening to a server. So listening to uh, this is a server, so we'll be listening to the clients. So we'll accept clients now. Else with a p error, and then do listening fail. Okay, so the final process is, of course, accepting the connection. So and accept, of course, the main principle of the accept function should extract the first connection of the queue of the pending connections, create a new socket with the same connection, the code and address only as soon as located and locate a new file distributed for a socket of possible. Okay, so this is finally taking the queue, the number of devices that is ready to listen to the server, and then takes the first first process or the first request, and then connects to it or accepts it. So accepting connections, and use a similar syntax. Okay, so for this we have to look at the arguments first. The socket itself, the socket file is filter the address and address length. So we need to calculate the address length in socket area. So first we have to typecast this, I guess. No, we don't need typecast it. Okay, we just need to typecast the second argument. Okay, let's go there. First we'll just define the size because we'll pass the reference to it. So size, we need the size of the client because the client is this the client is what we are connecting to. So student address. Okay. The first argument is of the server and the server client, and then the second one is of the client. Okay, so the client we're listening to, the address of the client, it will be stored in the client's uh, so it's client structure and also the size of the client structure. That's good. So the incoming client information is stored, and we will need to do struct of ADDR pointer and then the reference to the client. We need to typecast it, and then we need to pass the reference to the size variable that stores the size of the of my provide a client. I need to write a new if statement. Okay, so if and then we write uh, right. Okay, so it will return a connection. Find a connection file descriptor. Yes, I defined a connection file CPI connection file descriptor and then set it and then socket file descriptor and then the typecast so IDDR the pointer and then the reference to the client and the reference to the client. So we are passing a reference to the client because it's a double pointer. Oh no, it's not double pointer. It's just okay. We are pointer to this address. Okay. So we are just typecasting this. We are passing this address and then we're typecasting it to the sock ADDR type. So that is the sock address type from sock ADDR IN, which is associated with the internet to the sock address type. And then just check for validation. If connection file descriptor less than zero. So if it's less than zero, then we'll get an error, the error, connection failed, connection failed, and print a new line in the end, and well, they forgot to exit out of on the other cases, they forgot to exit. So let me just exit, we listen, and there's yeah, I have to yeah, it's fine. So else, so we'll see what errors connected. Connected and print a new line. And now I will refer to my old source code for the socket file descriptor undeclared. The names server file descriptor. Okay. Wait. Okay. Okay. Beautiful. So we need a client request to proceed, but the code is working, which is great. Now I'll define it. I'll just close the socket for now. Close. Uh, server socket server file descriptor. My bad. File descriptor. We'll close this process now and define a function called connection. So after connection, it specifies how interactive the server, and I just won't write it from the scratch. I will use my old code that I have written because it's quite simple. It's just the communicate function that takes the client's file descriptor and then assigns a buffer to interact with this, and then just read the data, then what prints what the client has said, and then let me just zoom in a bit. Yeah, print what the client has said, then provide then ask us to send a response, and then reads from a standard input, and then writes to the client's descriptor. And if we type exit, it will exit. So it's a very simple function, and I'll just copy paste it because well, it's very simple, and I have already covered these functions extensively. And there we go. And we close it. I just need this communicate and socket file. Oh, client file descriptor. My bad. We will be encrypting the client file descriptor. There we are. So basically, what it does is that it takes a client's file descriptor and then assigns a buffer so that we have a buffer to communicate, and then read from the client and then say what the client has sent us, and then ask us to send a response, reads from a standard input that is our keyboard, and then writes it to the client. And then if we get an exit call, that is, if we type the string exit, then it will exit out. And to use exit and the str and cmp, which is used to compare to string, we need the string library. And I guess we need one more thing that I want to add, that is the b0 function. So it comes in the strings strings.h header file, and it will just clear our buffer so we don't get a backlog. And b0 is strings.h. b0 function uses the data in n bytes of the memory, starting at the location pointed by the s and then writing zeros to it. Okay, so we just need to assign the buffer. Mm, I'll just do it in the start. B0, and then this buff as the buffer, and then the size of this buffer real, and then just try to compile this file. I hope. Okay, client file descriptor. Okay, connection file descriptor. Okay, and write connection in here. Connection file descriptor, and now it's fine. It's running, and we don't get any errors. So this is what the uh, server code looks like. Mm, we follow the standard processes that is defined in this manual, I'll say, while working with sockets. That is to create a socket, to bind it, that is address, assign the address, to listen to devices, to accept the first connection, and then start the communication. So for starting the communication, we need the client. So let's just quickly program the client. It will be very similar. I'll just copy paste it and go through it once, because it will be mostly the same except for one function. So the same communication function that takes the sockets file descriptor and communicates in this exact same manner. we have a socket file descriptor and a socket address. So we only need the address of the server. We create a new socket and then assign all those values, and we assign this to be the local host because uh, the server will be running locally, and then connect with the server. We use this connect method and and pass it the arguments, and then if connection is succeeded, we use this communicate method which returns us the connection file descriptor. So for that we'll just create this thing. I guess I haven't added the b0 here. The b0 that is that will allow us to create uh, just make the uh, buffer, just clear the buffer. So I'll just paste this. So everything is the same except for this connect method. So rather than listening to the calls, we'll just try to connect to this socket and just give it its argument. So the connect text takes man connect. The connect function shall attempt to make a connection to a connection mode socket. Okay. So it'll just try to make a connection to the local host, and then just it will take three arguments. It will take the socket itself to which it is trying to connect, and the address of it will just typecast it to the desired address of ADDR, not the sock ADDR underscore IN, and then the length will use the sizer for that. That's it. Basic socket and then down. This is oh, client. Go to client, 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 and client. Okay. Before this, client 72, line 72. Oh, there we go. There we are. So let's just close this and create two terminals and then just go to change directory documents slash C programming workshop and then socket, I guess, working with socket programming, same document slash C programming workshop plus working with socket programming, and we'll do an ls. Okay, so let's send the server and let's send the client. There we go. We can now enter the message. You can say hello, we the response is fine. And okay, we have to use the B0 in here. That's why this hello is appearing. This is a bug. Let's clear this. Exit it and let's close all of this. Let's need to recompile the client. First things first, we input the strings.h file. Mm, okay. B0 and then the bug and the size of the bug. Client. There we go. Now exit it. The server is running, clear the screen. The client is running, hello, and we get hello, hi. And okay, still getting this uh, undesired backlog, which means that is so everything seems to be working fine except this backlog, and for some reason B0 is not working here. Let's try to debug it if possible now. I won't spend much time trying to debug it if I'm not successful today, because I have had a long day today and it's been very tiring. But let's see if we have something to offer. So we have this Oh, we have this. Rattling this sound of footsteps. Flies. Ready. And then wait. Okay. We're still having a problem. Okay. Okay, we're still getting the error, and probably I won't try to debug it today, and because I'm already very tired, I have probably uh, like okay, we have passed across 2 hours, and I'm tired now, so I'll leave it like this for now. I'll try to debug it later, or maybe you guys can help me debug it. So yeah, I guess I'll just conclude it for today, and I guess you guys had a fun time. If anyone have any questions, then you can just ask me in the workshop. If not, then I'll just call it a day. Okay, I guess there are no questions. And okay, 2 hours and I guess 11 minutes is quite a long time. I guess I'll call it a day. Uh, See you guys tomorrow for the final day. Have a good night, and I'm sorry if I bored you guys. Yeah. Okay, peace, love, and hugs. Goodbye.